go ahead and open up your notebook, turn it to a fresh page, and press play when you're ready to continue. So there's two main types of problems that we're going to see with our order of operations extensions. The first one that we're going to look at involves 7 minus 5, and we'll go ahead and put those in parentheses. And then we're going to see an exponent that has work that needs to be done inside of the exponent like this. 10 minus 1 plus 3, and we've got a couple of sets of parentheses there, over 5 minus 2. So that whole piece up there is an exponent. So what I'm going to start with, if I'm thinking about PEMDAS, I need to start with parentheses, and I have a lot of different parentheses here, so I'm just going to work my way from left to right. So the first thing I see is 7 minus 5. That's my base. Those are my regular size numbers. 7 minus 5 is 2. Now I'm going to go up to that exponent, and I am going to evaluate the parentheses first. And just a friendly reminder, whenever you have a fraction bar, that means to divide. So we should end up with one whole number for this whole fraction setup up here. So let's go ahead and start up top where the parentheses are. So I have a first set of parentheses that starts right before my 10, and then I have what we call a nested set of parentheses, which is that second set that's inside of my other parentheses. So we're going to go to the most internal parentheses there, 1 plus 3. Okay, we're going to start with those nested parentheses, because once we're in a set of parentheses, we restart PEMDAS. So if we have another set of parentheses, we need to go there first. So 1 plus 3 is 4. I'm going to change my coloring here. And then 10 minus 4 is still in parentheses, which gives us 6 for the top number. I'm going to rewrite that over here, 6 for the top number. And then on the bottom of my fraction, I have 5 minus 2, which is 3. 6 over 3 means 6 divided by 3. 6 divided by 3 is 2. So that whole exponent is equal to 2. So now I'm going to apply that to my base number, which was 2. 2 to the second power is the same thing as 2 squared. 2 times 2, which gives us 4. Okay, so what we had to do there is we had to do some work within an exponent, figure out what that one number evaluated to, and then apply that to our base number. Why don't you try one of those? 8 minus 5 in parentheses, and then as an exponent, we have 3 plus 5 minus 4 over 4 minus 2. Press pause and then press play when you want to see me work through that at a quicker pace. All right, you guys, so I started with this set of parentheses, 8 minus 5 for my base number, which gave me 3. Then I went up and worked through my exponent. I saw I had parentheses up top, so I needed to start with parentheses. 5 minus 4 was 1, and then 3 plus 1 gave me 4 for that top of my fraction. And then 4 minus 2 at the bottom gave me 2. 4 over 2 means 4 divided by 2, which is 2. That whole work was just for the exponent. So now I apply that 2 to my 3. 3 squared is the same thing as 3 times 3, which is 9. The other type of problem I want to show you today is nested parentheses. Maybe I should have started here to kind of help with that first problem, but that's okay, we'll get there. So these problems are meant to look kind of confusing because they have a whole lot of parentheses in them. So go ahead, get this copied down just like that. And yes, there are 3 different sets of parentheses in there. Now that you have that copied down, press pause if you need more time. We need to figure out where to start, because if I'm thinking about PEMDAS, I need to start with parentheses, but this isn't the kind where I just work my way from left to right. This is what we call nested parentheses, which is parentheses within one another. So what we think about is, okay, here's my big set of parentheses around that part of the problem. But once I'm in those parentheses, I have to restart PEMDAS. And PEMDAS says I need to go and look for more parentheses. And so I start to do that, and I see I have another set of parentheses there. And inside of those parentheses, I have one last set of parentheses. So what you are looking for your starting point is the most internal set of parentheses, or the smallest set of parentheses, which is right there, 3 minus 2. That is our starting point. Once we get that down to one number, we get to lose that set of parentheses. So 3 minus 2 gives us 1. We got that down to one number, so we get to lose just that set of parentheses. Rewrite the rest of your problem, continuing to bring down the other parentheses that you have not used yet. You only used one set. Now we go to the next most internal set, which is right here, 8 minus 4 minus 1. Since it's all subtraction, we can work our way from left to right. 8 minus 4 is 4. And I still have 4 minus 1 that I need to evaluate. So 4 minus 1 is still in that first most internal set of parentheses, so I need to do that next to get 3. Now that I got that set of parentheses down to one number, I get to lose that set of parentheses, but not until I get them down to that one number, 3. Now I just have that one last set of parentheses, 20 plus 3, which is 23. Now I get to lose all of the parentheses and take 23 times 2. That gives us 46. So just to recap, you're starting with your most internal set of parentheses. You get to lose parentheses when you get that set down to one number. So we didn't get to lose these parentheses until we got this all the way down to a 3. Let's try one of those on your own, or you can listen as I walk through it. Press pause if you want to try it on your own, and I'll walk through the answer when you press play. So this one's going to be parentheses, 15 minus another set of parentheses, 10 minus 8 minus parentheses, 5 minus 4, close all 3 sets, divide by 7 on the outside. Press pause if you want to try this one on your own. Press play when you're ready to see the answer. So we wanted to start with the most internal set of parentheses, which is 5 minus 4. That gives us 1. That is down to one number, so I get to lose just that set, but I still have 2 other sets that need to be dropped down. From there, I now have this set of parentheses. I need to work my way from left to right because both operations are subtraction. 10 minus 8 is 2, and 2 minus 1 is 1. So now that's down to one number, but I have to do both of those steps to get it down to one number before I can lose those parentheses. My last step is to take 15 minus 1 because that's still in a set of parentheses, which gives us 14. I lose that set of parentheses. I get to divide by 7. 14 divided by 7 is 2. If that would not have worked out, this number was not divisible by 7, that's usually an indication that we have an error, so we want to go back and retrack our steps. All right, you guys, that's all I have for you today. Those are the 2 main types of exceeds problems that you'll need to know for the assessment and study guide. Check in with me if you have any questions.